Welcome class. We are going to talk about point slope form, and point slope form is just another way of writing a linear equation where you can graph. This is very similar to slope intercept form, and it also ties in with standard form, and later on in these notes we will learn how to actually write all three. So point slope form is y minus y1 equal to m parentheses x minus x1, and where m is the slope and x and y1 is an ordered pair or a point that's on that line. So the first step into writing point slope form is determining the slope, and you're going to pick your point either from a graph, a table, or the points given, and step 3 is to plug into the formula. So with our first example, we have write an equation in point slope form when given the point 3, 2, and the slope m equals 5. So we know that point slope formula is y minus y1 equal to m parentheses x minus x1. So we already know that m equals 5, and that is our slope, and 3, 2 is our given point, otherwise known as x1, y1. So all we have to do is plug in our given information. Nothing is needed to be solved. So I have y minus y1, which is 2. So y minus 2 is equal to slope, m is 5, parentheses, x minus x1, which is 3. Okay, so there is our point slope formula when given the slope and a point. Our second example, it says write an equation in point slope form when given 2 points. So I have point 2, 1 and point 1, negative 1. And the first thing you have to do is find the slope. We have to find out what m is. So that's our first step here, is to find the slope. Okay, so with 2 points given, I can use slope formula. And we know slope formula is m equals y2 minus y1 all over x2 minus x1. And from there, I can plug in my given points. So it is okay to label what they are so you know which one goes in which place. So we know that y2 is negative 1, and then we have y1 is 1. So negative 1 minus 1, then x2 is 1, and x1 is 2, so I'm going to subtract those 2. And then we're going to simplify. Remember to keep, change, flip. And when I do that, I'm going to keep the negative 1, change my negative to a positive, and then my negative 1 turns to my 1 turns to a negative 1, so now I have negative 2. And then 1 minus 2 is a negative 1. But we can simplify. A negative over negative is a positive, and 2 over 1 is just 2. So our slope is 2. So now we can pick either point. We can pick the first set of points or the second set of points to plug into our formula. So that is the second step. Pick point to plug in. And it doesn't matter which ones, but I can choose 2, 1 in this case. So I'd have y minus y1, which is 1, equal to m, which we already found to be 2, parentheses x minus x1, which is 2. Now note you can pick that one, or if you choose the 1, negative 1, you can do y minus y1. But do not forget our parentheses. So it would be a minus negative 1 equal to 2. Then we have x minus x1, which is 1. So either way, this will work. Always can simplify the last one. So that I have y plus 1 equal to 2, x minus 1. And it's plus 1 because I have a negative 1 times a negative 1 is a positive. So either one of these is acceptable writing in point slope form. All right. Now our third one is to write it when we have a graph. So write an equation in point-slope form when given the graph on the right. So this is where we can pick 2 points, or we can use rise over run, because regardless, we will still need to find the slope. So step 1 is still find slope. And you can do this by using rise over run or slope formula. Okay, so when we do that, we can pick 2 points. Let's pick these 2. We're going to rise up 2, and we ran 1. So 2 over 1, and my slope is increasing, and so my slope is 2. Or you can choose 2 points, and if you still choose these 2 points, you have 0, -5, or you can choose 1, -3. Either one of these is fine, and you can plug this into slope formula. However, or a point, you would stick this in the slope formula, but regardless, you will still have 2 as your answer. And then you have to choose, same part, choose point to plug in. So in this case, you can choose either, but I'm going to choose 0, -5. So I have y minus y1, but y1 is negative, so I have to put it in parentheses, equal to m, which we found to be 2, open parentheses, x minus x1, which is 0. So if we do that, we can rewrite it, and we can have y plus 5 equal to 2 parentheses x minus 0. If you decide to choose the other point, you'll still end up with the same thing. So if we chose 1, -3, we end up with y minus y1, which is -3, equal to 2. Then we have x minus 1. So either one of these works. Just make sure you watch out for those double negatives. So y plus 3 equal to 2, x minus 1. So either one of these answers is acceptable, writing in point-slope form from a graph. Okay, so if there are any questions, again, feel free to pause, and you may also take that time to write out anything you may have missed. I'm going to flip over to the next page on the back. Okay, on the back side, we have changing one form to another. So the first step is to determine the slope. Our second step is to plug into slope form. Our third step is to solve for y to get the slope-intercept form. Our fourth step is to move x over to the same side as y. Ax plus by equals c, otherwise known as standard. It says if ax is negative, multiply the equation by negative, and if ax is a fraction, multiply the equation by the denominator. Okay, so when determining the slope, we have to remember when we determine the slope, you can use rise over run if you have a graph, or slope formula. So remember, slope formula is y2 minus y1 all over x2 minus x1. Okay, and then we're going to plug it into point slope form, which we did on the back. And remember, point slope is y minus y1 equal to m, parentheses, x minus x1. So that is point slope form. Then we're going to solve for y. So solving for y to get y equals mx plus b, or slope-intercept form. And then we're going to move x over to the same side as y to get standard form. Okay? And so these two things are very important if you have a negative or if you have a fraction. So keep those in mind when talking about a times x, where a is the coefficient. So it says write a line that passes through the points 1, 2, 3, -4. And so let's label what those points are. So we have 1 is x1, 2 is y1, 3 is x2, and negative 4 is y2. And so since we're given 2 points, I'm going to use the slope formula to find my slope. So m equals y2 minus y1 all over x2 minus x1. And I'm going to go ahead and plug in my values. So I have negative 4 minus 2. Okay, so y2 minus y1. Then I have x2, which is 3, minus 1. Okay, so then I'm going to solve. So negative 4 minus 2, you have to change it to a positive, flip to a negative. It's negative 6 all over 3 minus 1, which is 2. And I end up with a slope of negative 3. So I found the slope as negative 3. Check that off of my list. So now I need to insert into point slope form. And remember, point slope form is y minus y1 equal to m parentheses x minus x1. So if you're going to choose, let's say you choose 1, 2. So then my equation would be y minus 2 equal to negative 3, which is my slope, parentheses x minus 1. Okay, so that's one way. Or if you're going to choose 3, negative 4, then your point slope would be y minus a negative 4, okay, equal to a negative 3 parentheses x minus 3. Just make sure you simplify for those double negatives. So I would have y plus 4 equal to negative 3 parentheses x minus 3. So either one of these is acceptable for point slope form. Alright, so now our third step is to solve for y. So we're going to put it into slope-intercept form. So if I'm doing the first one, where I chose 1, 2, I have my point slope form. And just like regular solving, I'm going to distribute my negative 3. So I know y minus 2 equal to negative 3x plus 3. Now I don't have y by itself just yet. I have to add 2 to both sides. And so then I would have y equal to negative 3x plus 5. Now if I chose the other, I end up with y plus 4 equal to negative 3 parentheses x minus 3. I'm still going to do what I did before and distribute that negative 3. So I have y plus 4 equal to negative 3x plus 9. So this is distribution. Okay, so then I'm going to subtract 4 because I still need y by itself, and now my equation is y equal negative 3x, and then 9 minus 4 is a positive 5. So no matter which set of points you chose, I still ended up with the same equation for slope-intercept form, which is y equals negative 3x plus 5. Now again, you can choose either, but regardless of whichever you choose, you still end up with the same answer for slope-intercept form. Then we need to move x over to the same side as y. So we already know our equation is y equals negative 3x plus 5. But I need to move my x to where it's on the same side with y. So this means I'm going to add 3x to both sides. Now note, I cannot combine these two terms because this has an x and this is a y. These two are not the same. So then my final equation is 3x plus y equal to 5. And let's double check. I don't have a negative and I don't have a fraction, so this is an acceptable standard format. Okay. So now we have example 2, very similar to the one we did before. However, we're going to write this in all forms. Okay. So we're going to pick 2 points, and I'm going to pick a different set of points. I'm going to choose this one, which is 3, 1, and then I'm going to choose this one, which is 1, -3. So again, I'm going to take my steps of finding the slope, and again, I can rise over run, or I can use the slope formula. So I'm going to choose rise over run. Jumped 1, 2, 3, 4, and 4 is acceptable because my scales are by ones, and then I'm going to jump 1, 2. And so we rose up 4, and then we ran 2, and so 4 over 2 is 2, and my slope is positive because my line is increasing. So now we need to write it in point slope form. So in point slope form, we can choose either point. I'm going to choose 3, 1. So if I'm choosing 3, 1, we have y minus y1, which is 1, equal to 2, which is our slope, x minus 3. So there is our point slope form. So we've already written one way, and this one was point slope. Okay, so now we need to distribute in order to make this into slope-intercept form. So if I'm going to do that, I still have y minus 1 equal to, I'm going to distribute my 2, so I have 2x minus 6. Okay, so 2x minus 6, but I'm not done yet. I have to get y by itself, so I'm going to add 1 to both sides. So then I have y equal to 2x minus 5. And look at that. This proves true because our y-intercept is at 0, -5. And look at -5, which is our b, also known as our y-intercept. So we have done this correctly, and we have found our new form in slope-intercept. So there is slope-intercept form. And now we need to put it in standard form. So when we do in standard form, we have to move the x over. So I'm going to move the x over by subtracting. So then I'm left with -2x plus y equal to -5. Okay, so this is where standard form you have to check. Do I have a negative or do I have a fraction? And look at ax. Ax does have a negative to it. And our step says if ax is negative, we have to multiply the entire equation by a negative. What we mean by a negative, we mean by a -1. Okay? So we're going to do just that. So I have -2x plus y equal to -5. So I'm going to multiply the entire thing by a -1. So that means it's going to change my entire signs. So when I do that, I'm distributing the -1 to each term, even across the equal sign. Or you can write it this way. So that way, this is another way of doing it. So you are distributing all across, or you're doing it to both sides. Regardless, you're still working within changing your form. So if I'm distributing from the top, -2x times -1 is a positive 2x. Okay, and then I have a -1 times a positive 1y, so that makes it a -y. And then I have -1 times -5, and that gives me a positive 5. Okay, so there is our standard form. I have no more negatives, and I do not have any fractions. So now we've written each form based on the given graph. Okay, this concludes my section notes over point slope form and writing one form to another. My tutoring hours on Wednesdays at 6:45 to 7:15 and Thursdays 3 to 5 o'clock. If you have any questions, please feel free to contact me, and always work on iExcel, and you know what those logins should be. Thank you so much.